Welcome to this video on domain and range of continuous graphs. By the end of this video, you should be able to determine the domain of a continuous graph, and you should also be able to determine the range of a continuous graph and write the domain and range in interval notation. So in the last video, we talked about discrete versus continuous. Discrete were individual points that were on a graph. Continuous meant they were connected by a line or a curve. So today, all of our graphs are going to be connected by a line or a curve. Remember, we talked about domain. Domain is the x values. And x values are left and right, so you're going to always read your graph from left to right. So you always start on the left and move to the right. And for the range, we're going to read our graph from the bottom of the graph to the top of the graph. So from the bottom to the top. And what happens when we read this, when we wrote our domain and range for a discrete, we always wrote the smallest number, then the next smallest, and we got bigger as we went. When you start at the left side of the graph and go to the right for your domain, that is the smallest number to the biggest number. For your range, when you start at the bottom of the graph to the top of the graph, that's the smallest number to the biggest number. All right, so we're just trying to identify x values and y values that are part of the graph that's given to us. And the idea behind this is if you knew somebody and you were trying to describe a person to somebody else, you would tell them they have blonde hair, they have blue eyes, they are 5'6", and you would try to give a description so the person you're talking to gets a picture in their mind of what this individual looks like. This is the same idea. It gives us an idea of what the graph is doing on the graph without on the coordinate plane without actually being able to see the graph. So I actually want to start with number 2 and then we'll move back to number 1 and see how that does. So for the x values, I want to know the smallest x value that is on the graph and the biggest x value that's on the graph. So in the circle, my x values never go past this point. And they never go past this point. They're between these two x values. So my smallest x value is -1, 2, 3. And my largest x value that will be on the graph is a +3. And so interval notation looks like this. You're saying, I'm talking about x values because it's domain. And the domain I'm going to have between -3 and +3. Everything's going to fall, every x value is between -3 and +3. So the x's, we're always going to use a less than symbol when we do this. So this says -3 is less than the x's, but all the x's are less than +3. So you're taking two different inequalities and you're putting them together. Okay, so our x's never go outside these two numbers. Now what about our y's? I have a very lowest spot on my graph, and I have a very highest spot on my graph. So my very lowest spot is -3, and my very highest spot is +3, and all of my y values are between those two numbers. So -3 to +3, and we're talking y values because we're talking range, so you want to put a y in there. -3 is less than all the other y's, but y's have to be less than +3 because it has to be between these two numbers. All right, what if I can't really box this off? This graph has arrows on the end. That means I'm just seeing a portion of the graph. It's continuing on forever and ever and ever and ever and ever. I just can only see a small section of it. So on the left-hand side of this graph, it's never stopping going to the left. Well, it's never going to stop. The numbers on the left-hand side of the x-axis are all negative. On the right-hand side of the x-axis, they're all positive. But if they never ever stop, they're going into negative infinity. That means it's never ever ending. It's going on forever and ever and ever, but in the negative direction because x values are negative to the left. X values are positive to the right, and it's never going to stop going to the right. So that's positive infinity. So all of my x values are between negative infinity and positive infinity. Now you cannot be equal to infinity because infinity is not a number. So we're just always going to use the less than sign here. Now, this is one way to write it. The other way to write it is what this really means is there's not an x value that doesn't show up on the graph. So we can call this all real numbers. These say the exact same thing. So, and I'm not sure which might show up on an end of course test, so we're going to teach you both of them. Negative and all, this is all of the numbers are included, and so here we can say it as all real numbers. Now our range, we have a very lowest point. It's right here. The graph doesn't go past that y value, which is -2. But on this side, it's never going to stop going up. So it's going to go into positive infinity on this side. So my y values are between -2 and positive infinity. So my y values are between -2 and positive infinity. So you got to put a y. This is a closed line. It's not dotted like when we were doing our inequalities. So that means it can be equal to. And you cannot be equal to infinity because it's not a number. So we'll use a not equal to symbol there. Now, this is one way. This says all the y values are between -2 and infinity. When infinity is on one side, you can ignore the infinity part and just write this inequality. And usually we write it with the variable on the left. So if you use our symmetrical property and we change this all the way around, we're going to say y, and see how the bigger side of the inequality symbol is to the y? You want to keep that the same. It gets turned around too. Y is greater than or equal to -2. So these two guys say the same thing. All right, so let's look at number 3. I always tend to do domain and range first. There are arrows on both sides. That means it's never going to stop going to the left. It's never going to stop going to the right. So all my x values are between -infinity and positive infinity. We can't be equal to infinity, so I'm going to just use my less than symbol. And the alternate way of writing that is all real numbers. So that's my left and right. Now let's look at my range. I have to ask myself, is this graph ever stopping going down? So it's going out to the side, but we already dealt with our left and right. Now we're talking bottom to the top. Is this ever going to stop going down? So for y values, it's never stopping going down. So it's going from -infinity for y's, and it's never going to stop going up. So we're talking about positive infinity for the y's. So all my y values are between -infinity and positive infinity, which the same as over here. That means all real numbers. All right, let's try one on the back. Let's look at number 11. So number 11, there's no arrows, so that means it's between two numbers. So it doesn't go past this x value of -2, and it doesn't go past this x value of 1, 2, 3, 4, 5. So all of my x values are between -2 and 5. And then we have to go back and look. This is a solid circle. That means equal to. So we put an equal to symbol with our inequality. This is an open circle, so we're just going to have just the less than. So all of the x values that will be on a point, any of the points on this graph have an x value between -2 and 5. How about the y values? There's no arrows, so it's not going up or down forever and ever and ever. My very lowest y value is -2, and my very highest y value is 1. So all of my y's are between -2 and 1. This is an open circle, so we're just going to less than. This is a solid line. They didn't put a point, but it's a solid line, and so that's going to mean equal to. And so all of our y values are between -2 and 1. So this just narrows it down and gives you an idea of where the graph is located and what it's going to look like. So I'll do one last one for you, and then you'll finish the rest on your own. We'll look at number 7. So on number 7, it says it has arrows on it. So let's look at left or right. That means it's, but when we have a pattern that keeps repeating like this, it's going to keep repeating, even though we can't see it. So the pattern is continuing, but it's never going to stop going to the left, and it's never going to stop going to the right. So our x values are between -infinity and +infinity, and we can call that all real numbers. But it doesn't go up forever and it doesn't go down forever. It's located, it's bounded here. It never goes lower than -3 or higher than +2. So all of our y values are between -3 and +2. And it's a solid line. So we're going to use less than or equal to for our symbols. All right, so I want you to try and finish the rest of these. Let me know if you have questions. See you in class.